All right, so word problems, finally. Back in 7.1, 7.2, when we did applications of the exponential, I said, well, we're using a to some power, some a, it's a parameter raised to the t power, and that's not really what is done in actual practice. What's really done is the base is always e, and then you have this value inside of your exponent that changes how quickly or how slowly it grows. That's what is actually done in practice. So in 7.1, we would have to solve for a or something, and that would be the thing that determined how quickly we grew. In this, the base is always e. What you'd have to solve for then is this parameter inside of the exponent. So let's do some decay problems. A substance decays according to this equation. A of t is a naught e to the negative 0.034 t, where t is in hours. So two parts. Part A, find the half-life and round to 2 decimals. And part B, if you start with 510 grams, how long until it's 102 grams? Round to 2 decimal places. Okay, so half-life means half of the substance is gone. And we kind of talked a little bit about half-life back in 7.1 and 7.2. If you're doing something with half-life and they don't tell you a starting, that's because it doesn't actually matter. If I start with 10 grams, then at the half-life, I'm going to have 5 grams. If I start with 100 grams, and at the half-life, I'll have 50 grams. If I start with 1 gram, at the half-life, I'll have 0.5 grams. So, suppose we start with 1 gram. Then at the half-life, we have half of a gram. And what that allows us to do, it allows us to set up an equation where I have 0.5 is 1 e to the negative 0.034 t. Because at some time t, whatever half-life is, my starting amount of 1 is now 0.5. So we're going to be solving for t. We're going to be solving for t. We kind of did this, right? So let's isolate. I don't actually need that one here. Notice, if you had had 10 and 5, when you divide 10 over, you still would have ended up with a half. That's why it doesn't matter what starting amount you choose. All right, take a log of both sides. So natural log of 0.5 is the natural log of e to the negative 0.034 t. Why do we take a natural log of both sides? Because logarithms liberate powers. So the only way to get a variable out of an exponent is to use a logarithm. So this comes down. So negative 0.034 t times the natural log of e. That's the natural log of a half. Natural log of e is 1, because e to what power is e? The answer is 1. So I have this is linear, and I divide. So t is the natural log of 0.5 divided by 0.034 t. Right, so this is what we call exact. So I'll be checking that on the exam. If you do the exam problem and you give the wrong decimal approximation and Hawks gives you no points, but this thing is right, yeah, you're getting almost all of your points back. You know, maybe you don't get one of them. Okay, natural log of 0.5 divided by 0.034. Negative 0.034. So this would be, it'd be a positive 20.39. What hours? Remember at the beginning of the problem in the setup, they say it follows this equation where t is in hours. All right, for B, if you start with a sample of 510 grams, how long until it decays to 102 grams? Round to 1 decimal place. Sorry, not 1 decimal place, but 2 decimal places. So because I still want like the setup, I'm gonna put my paper right here instead of flipping. All right, so for B, so A naught, A of t, E we know, t. Because it says how long, that means we need to find t. So everything else needs to have a value except for t. So A naught is how much I start with. In this case, I'm starting with 510 grams. A of t is how much I have now. What I have now is 102. My time is the thing that I'm looking for, my question mark. Now, we know already that the half-life is about 20 hours, right? So if I'm going to go from 500 to 100, that's more than half that's been gone. That's a fifth of it gone. Sorry, 4/5 gone, so 1/5 is left. So this thing, whatever this time is, it has to be more than 20. If I, in the end, got something less than 20, then I would know, oh, there's been a mistake somewhere. It's either in this problem or in the previous one. All right, so my formula, or my function, so I know that my amount now is 102, my starting amount is 510, E is a number, so it's known. So first I'm going to isolate the E. So divide by 510. Take a natural log of both sides. I would honestly leave it as 102 divided by 510 so that at the end when you give the decimal approximation in Hawks, you haven't rounded too early. Why do we take a natural log of both sides? Because that lets us pull the power down to the front, which means we get negative 0.034t natural log of E equals the natural log of 102 over 510. But the natural log of E is 1. And this is linear. So t is the natural log of 102 divided by 510 divided by negative 0.034. So that's my exact answer for my approximate answer. So natural log of 102 divided by 510 divided by negative 0.034. 47, so 47.34 hours. $47.34 hours, which makes sense. So it's less than a quarter that remains. So that would be 2 half-lives, right? Roughly. About 2 half-lives. So if one half-life is 20, then 2 of them would be roughly 40, but I need even more to be gone. So I have 40 and then that extra 7 hours to get that little leftover bit gone. So to go from 500 to 100 takes 47 hours.